Hey guys, we are still continuing with the topic differential equations, and I have your notes for 7-1 day 3 pulled up. We have, in our first example, there is a differential equation there, and no matter what techniques you try to use to solve that differential equation, to do an antiderivative on it, you're not going to be able to do that. So we aren't going to know what the original function looks like in equation form. But we can, by investigating its derivative, we can kind of get a glimpse of what the graph of the original function would look like. So just keep in mind that the derivative just represents the slope of the function. So this whole equation right here gives us the slope of the function y. So if you want to know the slope at any ordered pair on the function, simply plug the ordered pair into here and you'll get pretty much what the slope looks like at that point. So that's what we're going to do. We're going to sketch, it's called a direction field. It's also called a slope field. So notice the title of the section is slope fields. It says sketch the direction field, same thing. So part A says sketch the direction field. Part B says now draw a solution curve. What do you think y is going to look like if it passes through the origin? Okay, so let's just focus on part A. In order to complete part A, we're going to take many random points and sub them into our differential equation as an x value and a y value. And we're going to figure out what the slope is at each point. So we may choose the point 0, 0. And we're going to go y prime is equal to 0 squared plus 0 squared minus 1. So at the point 0, 0, the slope is negative 1. You can choose the point 0, 1. Sub them in. Y prime equals 0 squared plus 1 squared minus 1. I get a slope of 0. I can choose the point negative 1, 1. Negative 1 squared plus 1 squared minus 1 is positive 1. Now, I can keep on going, but the thing is, it's already been done for us. So I think somewhere out there, there's there's a graphing calculator app for certain graphing calculators and a computer app that actually sketches the direction field for you. Of course, you're not going to have that luxury on an exam. But what they've done over here is they have, let me think about this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Someone has gone to the trouble to complete a table with 81 rows in it to see the slope at every position on this graph. So it looks like we count by a half. So a half, 1, 1 and a half, 2. They've done that 81 times. Okay, so then what happens is, let's say that at 0, 0, we're going to graph a slope of negative 1. So at 0, 0, what I'm going to do, if it were up to me to make all these little marks on my paper, I would just put a small piece of a tangent line that appears to have a slope of negative 1 at the point 0, 0. And then what else did I find? I found at the point 0, 1, the slope was 0. So I would go to the point 0, 1, and I would put a small piece of a tangent line right there that had a slope of 0. And I think we determined that the point negative 1, 1 had a slope of 1. So you can see that I would put a small piece of a tangent line right there. So this shows a slope of 1. This is steeper. This is steeper. And yes, I am going to ask you to maybe draw some of these, and you're just going to kind of guess. Everybody can pretty much draw a slope of 1, and I'll show you how to draw the rest of them. Okay, so that's how you would come up with a slope field or a direction field. So let's do one. Here's our differential equation. And you can see this graph is 13, it's 13 by 13. There are 169 places where we need to sketch sample slopes. Just kidding. We're not going to do that many. But here's the cool thing. Notice that your equation doesn't even have an x in it. So x can be anything. If you choose the point 0, 1, then y prime is 1 plus, you only have a place to plug in your y value, so your slope is 2. So for any x where the slope, for any x where y is 1, your slope is 2. How about for any x and your y is 0? Y prime is 1 plus 0, which is 1. How about when y is 2? 2 plus 1 is 3. Negative 1. Negative 1 plus 1 is 0. And I've really done these out of order, but that's okay. Negative 2. Your slope is negative 1. Okay, so let's graph some of these. I'm going to do the easiest. So everywhere that y is negative 1, we need to graph a sample tangent line that has a slope of 0. Everywhere that y is negative 1, we're going to graph a sample piece of a tangent line that has a slope of 0. So here I go. Just like that. All right, let's do another one. Everywhere that y is 0, the slope is positive 1. Okay, so everywhere that y is 0, so all along here, you need to make a sample piece of a tangent line with a slope of 1. So what I need you to do is you're going to draw something like this. You're going to aim for the dot up here, diagonal from it. Aim for the diagonal, aim for the diagonal, because that will give you up 1 over 1. Kind of like that. When y is 1, the slope is 2. So everywhere that y is 1, we're going to draw a slope of 2. Now let me tell you a quick, simple way to do that. I'm going to draw a sample piece of a tangent line through this dot. My tangent line needs to have a slope of 2. So it needs to appear to be headed toward this dot right here. So aim, when you draw your tangent line, aim for the diagonal that's 2 up. Aim for the diagonal that's 2 up, and so on. And when y is 2, the slope is 3. Aim for the diagonal that's 3 up. One, two, three, 4. I've done 4 of them. And how about when y is negative 2, slope is negative 1? I haven't done that one yet. When y is negative 2, slope is negative 1. There we go. All right, now you can see, yes, I could keep going, but you can see that wherever one of these functions occur, I believe there's an asymptote at y equals -1. So you know this is just going to keep getting steeper, okay? And I think wherever the function occurs, there would be an asymptote here. And it may be that the function occurs beneath the asymptote. It may be the function occurs above the asymptote. We don't really know just by sketching the slope field. Okay, so you can kind of get the picture of where that's headed. We're not going to do the whole thing. And back up, I forgot to finish the first problem. So I told you, it said sketch the direction field. I told you somebody already did that for us. I forgot to do part B. So it says use the direction field to draw a solution curve that passes through the origin. So we need to pass through the origin. I'm going to go over here and start at the origin. Now, here's what I'm going to do. I'm going to work away from the origin toward the right, and I'm going to let the tangent pieces guide me. And then I'm going to work away from the origin toward the left, and I'm going to let the tangent pieces guide me. So as I'm working toward the right, you can see that the tangent piece leading away from the origin is telling me to head down like this. And this one is kind of saying, whoa, whoa, not so fast there, right? And this one's saying, okay, start heading up, head up, 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 steeper, 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 steeper. So that's kind of what it's going to look like. Just let them guide me. You don't have to make sure you hit a certain number. You don't have to make sure you touch any of them. Just kind of let the pieces guide you. And then as you work to the to the left of the origin, the piece leading away is telling you to go this way. So you're going to head up like this. This is like, oh, not so fast, not so fast. Come back down, come back down, come back down, really steep. So this kind of gives you an idea of what the original function's shape was. I'm sure that there's a family of functions that pass, have all kinds of heights and y-intercepts to them. And this would just be the graph of one member of the family of functions. Which member is it? It's the member that passes through the point 0, 0. Now, that was easy, quick. A lot of what you do on tests and quizzes and stuff like that for slope fields is multiple choice. So a lot of times you're given a differential equation and you're given several slope fields to choose from, and you've got to choose. Let me just warn you right now, be thorough in finding which one works. Or maybe you're given a slope field and several differential equations and you have to match them up or whatever. Be thorough, okay? Don't just find one point and be like, finally, I found something that works. This must be it. Check several. Keep checking, okay? Good luck.